So, welcome everyone. I'm Nicolai Parlog, Java developer advocate at Oracle, and today we're going to here to talk about Java Next, from Amber to Loom, from Panama to Valhalla. So, specifically, why do I talk about these projects? And if you don't know those names, what are they even? Java is developed under the umbrella of OpenJDK, the OpenJDK community, and every time a big problem is identified, somebody can sit down and thought, like, I have a smart idea about this. Let me, create a project that thinks about this problem long and hard, and then eventually surfaces a solution, hopefully. And so these 4 projects deal with 4 very important shortcomings of Java, and we're going to go through those. These are the most important ones right now, but there are definitely more. As you can see, the slides are already online. If you go to slides.nipafx.dev, you can see them on the right-hand side. So in case I get a little too fast, you can look in there. I might get too fast because this is a 60-minute talk, but if you looked at the schedule, it's only 45 minutes. So as Brian Getz once said, I prepare too much, so I'm going to talk too fast. Okay, let's get going. Let's talk about Project Amber. Project Amber has the goal to create smaller, productivity-oriented Java language features. Everything green, at least on these kind of pages, is a link. So if you want to follow up on the project, the wiki, the mailing lists, I invite you to do that. The aforementioned Brian Getz launched this project in 2017. And the motivation is to overcome certain downsides of Java, namely that Java can be cumbersome. It tends to require some boilerplate in specific situations because it lacks expressiveness. We want to express something, like this is a simple bean-like structure, and the Java language doesn't know this concept, so we have to go through the effort and creating all the boilerplate around it. And Amber wants to solve that, but different from what I just said, it's not so much one problem and one solution. Amber is more like a solution factory. So Amber is going to continuously tackle these kinds of problems. So when one is fixed, surely the next one will present itself, and it's going to keep working on that one then. And already delivered quite a lot of different things. So from bottom to top, in the order in which they were released, you see local variable type inference. You see a bunch of stuff around about starting pattern matching, like type pattern matching is in there, records, seal types. So already a lot happened on that front. And much of what Amber is concerned with right now can be summarized under pattern matching. That's Amber's main thrust, definitely at the moment. So if you take together switch expressions, sealed types, records, and the patterns that we already saw, the type pattern matching, then you get this capability of pattern matching. With that, you can write code in a different way. Like one phrase to put this under is data-oriented programming, which is similar to functional programming. It's definitely much more similar to functional programming than to object-oriented programming, but the focus is not on the functions that you're writing, the focus is on the data that you're processing. Either way, I created a YouTube video about that a couple months ago, so you're invited to watch that, and then there's more talks, definitely, and there's also more text and videos about that online. So you can research a lot of that on your own. I'm not going to repeat all that. Instead, I want to talk about something that's a little bit less, a little bit newer, and a little bit less talked about at this point. And that's string composition. Okay, so let's have a look at string composition in Java. So what I'm trying to do here is, I'm trying to create a select statement. Where's my slide thingy? Oh, man. Oh, there we go. Okay, that took a while. There it is. Okay, cool. High tech. Right, so I'm creating the select statement, right? And I want to put the property that I'm querying and the value that I'm querying for into that statement. I know you're not supposed to do that, I'm aware. But, just for this example, I want to do that. I have 2 options, right? I can either just use regular concatenation, I can use string formatter, and the reason why I'm not supposed to do that, of course, is that this comes with the SQL injection. Good. And it's cumbersome. So other languages have other capabilities. Why not something like this? This syntax here, I'm going to claim for now it's made up, which uses / curly brace, and then I reference the property, the variable that I created earlier, and I reference the value variable that I also created earlier. And that's great, right? That would be so much easier, so much faster. We get our SQL injections much quicker now. Which maybe isn't ideal. So, let's put a pin in that. SQL injections are not the only concern here. Generally speaking, we don't usually create text for humans to read in code. It happens definitely, like tooltips and whatever, or error messages, but mostly we're creating text for other machines to read, right? It's structured text like HTML, JSON, YAML, whatever, and all of them have format-specific rules. All of them, you don't just want to create something that looks like JSON, you want to create a valid JSON string, for example. And this is where string templates enter. String templates look like this thing, meaning I use a text block here with the 3 quotation marks that was introduced and finalized in Java 15. But the process I'm explaining here has nothing to do with text blocks. It works with regular string literals too, so you can ignore that if you're not familiar with it. But what I'm doing here is I'm using this syntax that I made up with the backslash here, where I use the property and reference the value again. But I have this thing there before, it's str period. So there are 2 things at play here. This is a template expression, and it has 2 ingredients. The first one is the template string. That's the part, that's the text block here that starts here and ends here. And the second part is the str. That's the template processor. So these 2 ingredients. And that means we first create this templated string, which has some embedded variables or expressions in general, and then we throw that thing as the template processor, and what we get back is that string there. Not the asterisk behind string. We're going to get back to that in a couple minutes. So what different template processors could there be? Well, there's one very simple one that could be called str, which does nothing. It just concatenates the strings. Like, it's not smart. It doesn't do anything fancy. It just takes the strings that you give it and the values that you give it and just puts them together as you would expect, right? So in this case, I'm creating this payment slip here, and it's pretty obvious. I have some variables here, like a variable called price and a variable called quantity, and I embed them all here. I can do some math as well, like here's the multiplication, and that's all fine and dandy, works well. Has the slight disadvantage that I'm now supposed to pay a fraction of a cent, which turns out to be troublesome in practice. So there could be another processor that's a little bit smarter, like this one. This one could be created to understand the formatting strings that you can embed in string.format. I always had to look them up. I can't remember them, but this one's right, like %5, I think means 5 digits, and I want to have 2 after the decimal point, something like that. Anyway, we do this, and now we get a nice rounded number. We get a good payment slip. Notice that this is the same templated string, but it's a different processor, and this processor does something different with it, depending on what the processor's task is. Okay, I said earlier that there's an asterisk behind string. Why are we talking about strings here? I said earlier that very often we're creating structured text for another system, for another subsystem. And so there are many situations where it's not actually helpful to start with something that we consider half a string and half a set of expressions that we want to put together, and then somebody needs to validate and see whether that's actually, let's say, an SQL string. And once somebody, like the two, decide, yes, it's actually a valid SQL string, then it turns into a string, like a very stupid string, and then the SQL parser comes along and parses it again to use it as a statement. Why do we use a string as the intermediate representation? It seems like we're taking a detour here, and indeed, we don't need to take that detour. From now, let's look at the top. That's the top interface in the small inheritance hierarchy that is created. It's called validating processor, and it takes as an input the string template here, and as an output, it gives a generic result. Any kind of result. So this validating processor does not have to create a string. It can create other things too. Now there are two specializations for that. The one specialization, template processor just doesn't throw an exception, right? So this one, because that one you could see, like maybe the SQL isn't good, so it needs to maybe throw an exception. This one cannot throw an exception, only runtime exceptions. And the one at the bottom specifically creates strings. But those are just specializations. They're not that important. The top one is the important one. Give me a string template. Right, give me a string template, and I'm going to give you back something, depending on what kind of processor I am. So we could easily assume that something like this might be created. This SQL dot. What this is, SQL is an implementation, it's a variable name for an implementation of that interface. So you create an implementation for the interface, and then SQL is basically a static variable that you make available. And usually you would call .process, but because that would be very lame and would be like all of the like a lot of ceremony, there would be a special syntax invented. So in this specific case, you don't have to call SQL .process. Here's my templated string. But that's basically what's happening. The string and the properties. The string and the expressions are evaluated, and then they're passed to this method that we just saw, and that returns any kind of result, and this one might then return a statement. And this thing can then make sure that there is no injection, right? In this case, by properly escaping everything. You could create prepared statements in the background. Everything that you need to happen for SQL statements to work properly, you could put into that processor. And this one does not have to be provided by the JDK. This could be this one specifically could live in the Java SQL module, right? But we could also create this on our own. Like, there's no magic here. This is open to us to improve, for example, something that creates JSON right away. So template strings are JEP 430, and they are a candidate for JDK 21. So there's a really good chance that in JDK 21, we're going to see this as a preview feature, probably. So it will not be finalized in JDK 21, but you can start experimenting with it very easily, hopefully in September. But as I said, Ember is doing much more than that. It's dealing a lot with pattern matching. There's links to all the JEPs that are currently being looked at. So pattern matching record patterns in JDK 20, they're all in another round of previews. Primitive types and patterns and unnamed patterns and variables, there's drafts for that. But Ember is having their plate full of things that they can look at. So for example, there have been discussions about a simplified main method, about an easier way to start that does not include public, class, whatever, curly brace, public, static, void, main, string, bracket, bracket, args, curly brace, and then finally the code, because it turns out that if people want to start out with Java, you already have to go into either a lot of details about the language to explain to them how to write hello world, or to tell them I know you want to learn, but let's ignore 80% of what you're writing in that file. And both of that is not like great starting points for somebody to learn Java. So that would be mainly addressed at beginners or at like people maybe already know programming and want to switch over to Java. Like in any large program, that's not going to make a difference. But it's very interesting for people who are new to Java. There are discussions about relaxing the necessity to have no statements before a super call. Right? If you call super or this in a constructor, it must be the first statement, right? There's a reason for that, but it also hurts. And maybe we can relax that reason, and then maybe we can do a few things before calling this or super. Concise method bodies is about forwarding methods that just forward to another method. You could basically, so the idea goes, right, well, I have to implement add, but all I want to do is I want to forward to this inner collection that I have that also calls add. So I just write public void add, arrow, my internal collection dot add. So there's lots of ideas out there that Ember is still going to be busy with for quite a while. So Ember wants to make Java more expressive, wants to reduce the amount of code we have to write and to read. It's not about saving keystrokes. It's about removing redundancy. It's about making something more expressive and hopefully making us more productive in turn. Now, when does all of this happen? Now I'm going out of a limb here. Yes, I do work for Oracle, but no, you cannot sue me for this because this is my personal guesses. This is not reflective of my employer's opinion because my employer's opinion is it's done when it's done, which seriously is the only valid answer to the question, when will this happen? But also it's boring and everybody likes to speculate. So here's my speculation. Pattern matching and switch and record patterns have new JEPs that appeared, I think they were finalized yesterday, and they do not carry the preview anymore. So if these JEPs get targeted to Java 21, then pattern matching and record patterns will be finalized in Java 21, which would be huge. Template strings will probably preview in 21, I already mentioned that. And I hope, crossing fingers here, that we might see a first step to a more simplified main in Java 21. Although Ember is doing a lot in 21 already, so I'm not going to hope for too much. And then, but I'm sure in 2024 we'll see more of that. And I also hope to see more patterns becoming available, being previewed at that point. If all of this did not go deep enough for you, here's some material to follow up on. If you want to do more, as I mentioned, these are all links, and you will see them if you go to the slide. And we'll also tweet the link to the slides later. Okay, if you have any questions, find me later at the conference, because we have to go through a lot of slides, remember. Let's start with let's go to the next project, Project Panama. So it's totally different, right? Whatever you understood, or maybe even didn't understand just now, put that away, put it in a box. Now comes the next box, Project Panama. It's about interconnecting JVM and native code. It falls apart into 3 sub-projects: the vector API, the foreign memory API, and the foreign function API, the last 2 of which belong together. So we're going to look at the vector API a little bit, and then we're going to skip past most of the foreign APIs because they're very technical and they deal with stuff like C, and nobody cares about that, right? And also have to save some time. Okay, let's start with vectors. That's actually very interesting. So here I have 2 float arrays, A and B. And what I want to do is I want to compute C. So I want to take one number out of A, one number out of B, do some simple computation, and put the result in C. but not just for one pair with one result, but for lots of pairs with lots of results. This is the simple for loop that does that. Straightforward, going over the array, which we assume have the same lengths, pull out the values, do the math, write it. Okay, that looks good. It's all great. But it's really not optimal code. So modern CPUs, the one in this Lenovo laptop has, I think, 512 bits, have multi-word registers. A multi-word register is a register that can accept multiple words, which means, for example, multiple ints. So I could put like 16 floats in one of those multi-word registers. And then you can have 16 floats from A and 16 floats from the B array in two of those registers, and then do a single computation to create, out of 16 pairs, 16 results. And this does not take longer than the simple computation, right? So we just had a 16-fold speed up. We go from one addition with one result to one addition with 16 results. That's crazy, right? That's a huge speed up. And this is something that's behind the MMX extension. If you're old like me, they came out in the end of the 90s. This is very important for image processing, for encoding and decoding, for audio processing. This is what makes much of multimedia possible that we enjoy. It's called single instruction multiple data, SIMD. You might hear that occasionally. Now, the just-in-time compiler knows about this. It knows that this is something that the CPU can do, and it tries to hit those commands. It tries to understand the loop and figure out, does this loop allow to use these vector instructions of the CPU? And if it does, if it can find out that it does that, then it does this transformation. And then we get this speed up for free, which is really good because it just gives us free performance, but you cannot rely on it. If you actually need this to happen, then you cannot rely on this, because any simple refactoring of a loop can actually break that auto-vectorization. And this is where the vector API comes in. So the vector API has nothing to do with the old vector class. And I'm not going to go over all the details here. What's important is the part that I still get A and B as input float arrays, right? And what I do then is I pull stuff out. I say, okay, give me a float vector from the array A, and give me another float vector from the array B. And now let's do something we all enjoy. Let's do some math with method calls like big integer. Let's do the multiplication and then the addition, and then we get vector C. And then at the end we say, okay, vector C, write that into the array C. So I accept that this is not actually more readable than the code we saw earlier, but it's still fairly readable. And what this allows, though, is for the just-in-time compiler to always hit those vector instructions. This API is platform agnostic, so it doesn't matter how many bits in this multi-word registers you have. Doesn't matter. You can always use this, and the just-in-time compiler will reliably hit these instructions if they're available. And if they're not available because you're running on very old or very limited hardware, you will get performance that is not worse than the loop that you would otherwise have written. And that API is currently in preview, incubating. We'll see that. We'll talk about that in a minute, and we'll hope to see that soon. So that's one part of Project Panama, and that part is very mature already. Let's talk a little bit about foreign memory API and the foreign function API soon. So again, this is a different topic, right? Not unrelated to vectors. So sometimes you want to store stuff off heap. There's a variety of reasons for that. Some good, some not so good, but people want to do it. And mostly there's two options. There's byte buffer, which is limited and not that fast, and there's unsafe, which is great, but unsafe. So maybe you don't want to use it. Unsafe could any refactoring, any minor release of a new JDK could technically break your code. So you don't want people to use unsafe. And this is where the foreign memory API comes in and says, okay, look, we have to solve this problem again, but better. And just like when Java had the old calendar API, which was like basically two classes like calendar and date, and then the new datetime API in Java 8 had like dozens of types. It felt like it made the problem so much more complex. But what it really did is it reflected the complexity of a complex domain in the types that we use. The problem of calendar and date was that it's trying to sweep too much complexity under the rug. And that's similar to something that happens with byte buffers. So the new foreign memory API will have more types to go into more detail, to give you more chances to allocate memory, to deallocate memory, to do that thread safe or not, depending on whether you need it, to control deallocation, which you could not do in the past, which is not something that Java usually needs you to do. But if you're reserving like 5 gigabytes on the heap somewhere, maybe you want to get rid of that as soon as possible and not wait for some random small object of yours to be garbage collected. So the for memory API works with the try with resources block. We create an arena that you open, and in that arena can reserve memory, and you can use that. As I mentioned, we're going to skip past that. But it gives you a much safer and slightly faster API. Now, let's talk about foreign functions. Because why are we even putting stuff off heap? As I said, there are good and bad reasons. One good reason to put stuff off heap is you want to call a native method. You have maybe a machine learning library or an image processing library that you want to call that's in a C library. And of course, the data it operates on better not be in the heap, because if the C library starts writing stuff in your heap while garbage collection happens, that's not going to turn out well. So you want to put stuff off heap where the garbage collector doesn't touch it, and then call your foreign function. So that's why these two are related. Now, foreign functions, you can already do that with Java native interface with JNI, but that's also not ideal. It has like a lot of artifacts and tools involved, and it's really cumbersome to keep specifically a fast-moving library adapted to keep working in Java. So foreign function API, again, tries to tackle this problem from the ground up, together with the foreign memory API in mind. And the key difference here is that it uses the method handles that were introduced in Java 7 to model calls into foreign code. And this very mechanical code, which calls into C, that can be generated with JExtract. So what you would do with the foreign memory API, foreign function API, you would take your C file, you would run JExtract, so you get a Java file which is very low level, and then you write your own Java API on top of that, something that it's more friendly to the way you want to use this native library. And if the native library updates, you run JExtract again, you get this low-level code generated anew, and then you get compile errors maybe between your Java class that you wrote and the Java class that was generated. For all these tiny differences that happen when the library evolved, you now get compile errors. You can fix those in your code, and that gives you more safety and it makes it easier to adapt an API. Again, we're going to skip over the details. Overall, Project Panama wants to connect Java with the native world and offers safe, more detailed, and more performant APIs for that. This time, I don't have to guess for the first part of the timeline. The official plans are that the foreign APIs and the second preview in JDK 20, and the vector API is still a way off. That's very unfortunate. It's very stable, it's very mature, it's doing its job really well, it's basically done. The problem is, once Project Valhalla comes around, and we're going to get to that next, it would probably change its API. And it would be sad to finalize the vector API now, and then like in 2 years be like, oh, well, it could be so much better if only would have waited. So we're waiting now. So the vector API still needs to sit around for a little while for Valhalla to progress. My personal guess is that the foreign APIs will finalize in 2024. Maybe if we're lucky, already in Java 21. That would make 21 even bigger. But I'm not so sure about that. We'll see. Again, if you want to dive deeper, a lot of links on the vector API. My colleague, Jose Pomar, just created a video, Fast Java, or learn how to write fast Java code with the vector API, the second entry here. Good video. It's like it came out the other day, so it's very up to date. If you want to learn more about the vector API, take a look at that. And there's a ton of design documents on the foreign APIs. As a tip, if you're interested in this kind of this evolution of Java and you want to stay up to date without spending too much time on it, focus on these state of articles. Whenever you see one of these state of articles, they're great. These are usually design documents written by the people who are working on this, where they're summarizing their current understanding of the problem and of the solution. They can be very technical, so sometimes it's hard to follow all details, but usually they have like a very gentle introduction, and they usually can get like 50 to 80% of them, and then at the end I often have to give up. But those are like highly recommended, great articles to learn more about these projects. Now let's go to Valhalla that I mentioned earlier. It's about advanced Java VM and language feature candidates, which is definitely the lamest of these claims or mission statements, because that could be everything or nothing. Also, it launched almost 9 years ago at this point, and it's not that close to being done. I'll come back to that in a second. Okay, so the motivation here is to address the fundamental split in Java's type systems. There are primitives and there are classes. Primitives are, numbers like int and double and float. And classes is everything else. And everything we create needs to be a class. which means everything we create has identity and has references. What do I mean by that? Identity is the reason why when you create new integer 5 and another new integer 5, while both of these are equal, they're not like equal sign, equal, right? They're not identical. They have an identity that lives beyond their value. And that's something that makes sense for some things, but not for others. And that comes with an overhead. It needs extra memory for the header. It allows mutability. And everything like with locking and synchronization also requires that. And that's stuff that we need, but we don't need that all the time. But all the types that we create have to pay this price. They have to be mutable by default. They have to have the extra memory for header. And every classes that we create, the instances are always references. That means there's always memory indirection, and they are always nullable. And again, some types need this, many even, but not all of them. And specifically if you've programmed in constrained environments, like maybe you're creating a game that's supposed to run on Android, or you're working with the tool where garbage collection pauses are an issue, or with the program where that is the case, you know that you really want to avoid creating like these. If you have, for example, let's say you have a point class that has like an X and a Y coordinate, and you have an array of points. That might be the way you want to write this code. But when you're performance sensitive, you realize, but that's not an array of like X, Y, X, Y, X, Y. It's an array of references that point to X, Y somewhere in the memory, and iterating over the array, which should be fast, is actually not that fast because you're constantly having cache misses. You need to fetch these memory pages. In most Java code, it doesn't matter. But in Java code, it does. And then you start doing things like, okay, I don't have a point array, I have an array of X coordinates, I have an array of Y coordinates. You have this conflict between design and performance, and that forces you in those specific situations to choose a subpar design. Project Valhalla wants to unify the type system. It wants to give us value types, which disavow identity. It wants to give us something with a shrug emoji, I'm going to get to that in a couple minutes, that disavow identity and references. And also comes with universal and specialized generics. I'm going to come to that, what that is. The relatively straightforward part is value types. So we have here a class rational number, but it's not just any class. It says value class at the top. So what I'm doing is I'm creating a class where I say, look, I don't need identity here. Any rational number and any other rational number, as long as they have the same values, they're the same thing. It's like int5 and int5. They cannot be different. Even the question doesn't make sense whether two int5 could be different. And this would code almost like a class. Very minor limitations. You could write the code, you could implement interfaces, add methods, all that stuff, all that good stuff. As I said, they don't have identity. That means some runtime operations won't work, but that's to be expected. They have null as a default value. They have an identity check with the two equal signs that has to compare by state. But the benefits I get for that, I have guaranteed immutability, which is great for various kinds of designs that you might want. You can more clearly express that this is a value. For example, think about domain-driven design where the term value actually has meaning. And it allows the JVM to do more optimizations because it doesn't need to track the identity of an object. It can destroy the object and just ferry around the fields, for example, and then later recreate the object around it. It doesn't need to track the identity of this one specific object. This is a quote from a JEP. The JDK, as well as other libraries, has many value-based classes, such as optional and local datetime. We plan to migrate many value-based classes in the JDK to value classes. So we expect for many current existing classes to become value classes in the future. Now, value types still are references. They still allow null. And that means we don't have this flattening that I talked about earlier, where I have an array of points would still be an array of point references. It would still not be an array of x, y, x, y. I'm still not there. Wasn't that like the big goal? So how do we get rid of them? And this is where the shrug emoji comes back. Because there have been a proposal called primitive classes that is still out there, but on the mailing list, there has been conversation about nullness markers, which sound very advanced, these considerations. So I'm at this point kind of assuming it's maybe going to be nullness markers. You're seeing I'm working off of publicly available information here. I don't back channel to ask Brian Getz, what can you tell me so I can tell it Vox Day Zurich, because it's not going to tell me anything. So I work off the same information that you could look into. So I'm guessing here. He probably knows which avenue he's exploring. I don't though. So primitive types were proposed by JEP 401. There's already a JEP for that, but it's probably going to be sidelined, I guess. Which works very much like what I showed you before, but you write primitive instead of value class. And then you get no identity, just like value types. But on top, you don't get references either. That means a complex number is not nullable. And that means there needs to be a default value, and the default value would be all fields set to 0, which makes sense. A complex number that has, complex number often has like a real part and an imaginary part, or it has a distance and an angle. Either way, both of those presentations make sense as everything is 0. That's good to go. But you're deciding when you're creating the class what kind of nullness behavior you have. But that doesn't always work out, right? It's like int at integer. Int says, no, I cannot be a class. I want to be a primitive. But we sometimes need the whole class thing around it to have a null for different kinds of reasons. So we kind of still need that box. And the proposal says, well, maybe we can just create like a new type that is complex number .ref, and that will be like then the box around it would be like the integer to an int. It's not exactly elegant. Looked like it's going to work, but it's not exactly elegant. And specifically, it creates an ad hoc solution to a larger problem. The larger problem being, how do you deal with null? And now nullness markers are being discussed, which is huge. I did not expect that at all. Just like a year ago, I made a talk where these are never going to show up in Java. So, right. So the idea is to get use-site nullness markers. You may know them from like TypeScript or Kotlin or Scala, where you have like a question mark and exclamation mark. None of the syntax is already being discussed. Like this is earlier. So the idea is like just somehow we're going to have these markers. What they look like is not important right now. And then the idea is you don't get primitive classes anymore. You have a value class. And let's say I create the value class. And you as a user say, I'm fine with this not being null. This variable will never be null. So you say I want to have a complex number exclamation mark. And then the just-in-time compiler or the JVM in general, they could figure out, hey, you know what? In that case, I can actually flatten this because you already don't have identity because it's a value class. You also opted out of nullness, so we don't need to reference. So let's go ahead, let's flatten this. And at that point, flattening is not something that is a design decision so much as it is an emergent property of the semantics that you decided in the program, where you said, this is a value and it can't be null. And then the JVM says, that's great, I'm going to use that for optimization, which is really, really cool because it surfaces this optimization in a way that has more semantic meaning to us. That is not a mere, well, I'm going to do this so I get better performance. Because usually languages fare better when they help you with your semantics and when you don't force you to deal with performance considerations. But all of this, as I say, is still very vague. Either way, we're going to get, hopefully, flattenable instances somehow. And those flattenable instances will probably achieve a performance that is comparable to today's primitives. So we will be able to create custom primitive types, or whatever they're going to be called, that will perform comparable to today's primitives, which is great, right? We can create a point class that will be just as good as if you're dealing with the x and y coordinates separately. Okay, so now we have this value and maybe primitive classes. We have all of that, right? So in the past, we had the primitives, and they didn't work with generics. That was acceptable to a point, right? Because we don't use primitives that much in a domain, so it did not collide with generics too much. But now everybody starts creating their own value classes. And suddenly, boxing and this problem with generics would become omnipresent, and that would not be an acceptable solution. So the proposal behind universal generics is, let us allow all kinds of types, even primitives, even value types, in generics. Obviously, huge step forward. Was kind of expecting applause, but okay, it's not my work either, so it's okay. But this is only, at that point, that would only be exposed in the type system. The compiler would accept this now, but what nobody would do at that point still is, well, okay, so the array list of long, that's still an object array. So it's great if the language does the thing we want, but it's not great if we never use it because we're again coming back to performance considerations. So universal generics means you can use every type in generics. Specialized generics means, and we're actually going to do the work of taking an array list of long to be backed by a long array, or an array list of int by an int array, as I said here. So specialized generics will allow generics or a primitive to avoid these references. There will be a big change. So value types, and that's something, plus the universal and specialized generics will primarily present us with fewer trade-offs between design and performance. That's the most important part. There's a fundamental conflict in Java, and that's being resolved by allowing us to write the code that we want and get the performance that we demand. There would be no more manual specializations like in-stream and long-stream and double-stream, and I think the person who was in charge of those specializations probably quit. That's why there's no float stream, I assume. I don't know. It would have better performance, right? Because all the low-level libraries that we'll be using, they could start using primitives or values, and their code could be optimized better, our code as well. But we're getting there by making good semantic decisions. We're deciding this is a value. I don't need this to be null, and we get the performance for free. We can express, as I said, the design more clearly, and hopefully we can create more robust APIs by sharing in more values, more immutable types. Because I think the biggest source, one of the biggest sources for bugs is sharing mutable state. And if all our subsystem communicate with value types, for example, those are not mutable. They cannot share mutable state. So overall, makes Java more expressive and more performant. I used to have a timeline here, but like even I don't dare guess anymore, because with the whole like out of left field, maybe we have nullness markers, let's discuss this for a bit. I have no idea how long that would take, but it feels like if we're only now starting the discussion on nullness markers, it's probably going to take like a year or two for any kind of proposal to come around. So I just gave up on Valhalla. It's just going to happen. I mean, like at that point, probably Amber, Loom, Panama, everything is done, and Valhalla is still like chugging along, trying to get value types. More links. The state of Valhalla, as I said earlier, the state of documents are great. These three are like the best ones, specifically the first two. The third one is tough to grasp, but the first two are just amazing. Highly recommend. And I want to take a small ad break, because it's not just these big projects that are being worked on. So many APIs are added and changed from release to release. We have new random number generator. You can now use Unix domain sockets instead of an HTTP loopback device, which is faster and safer. I mean, the domain sockets are faster. There's lots of internal refactorings going on as well. There's small additions to string math, so many things. Usability is constantly being improved. UTF-8 is now the default everywhere in Java. The simple web server, this is actually a website, and the simple web server is just a binary called JWebServer, which will start a small, simple web server that just hosts local files. Great for experimentation or for demos or something. Not to be used in production, of course. This is a great little addition. Tooling gets constantly better, specifically JFR gets a lot of love right now. Performance overall improves. Class data sharing, so a bunch of improvements. Garbage collectors, all garbage collectors, whether it's G1 or ZGC or Shenandoah, all of them get, even Parallel GC, all of them still get improvements and performance becomes better and better. Security is constantly being adapted to the changing security landscape. There's Sean Mullen, who's in charge of security at OpenJDK. He writes a blog, and that guy is amazing. He writes one blog post exactly every 6 months on each new Java release, and it's like, this is all the security changes in that Java release. I can highly recommend that. Like, it's all hit, no miss on that blog. But we don't only add things, or I shouldn't say we, I'm not actually working on this, I'm just talking about it. Not only things are added, they're also being removed. Very carefully, certain things, taken out the backyard, you know, get to live on the farm of states. Finalization, security manager, applet API, primitive wrapper constructors, and biased locking. There's a JEP for all of these. I encourage you to read those or watch one of the recent Inside Java newscasts where I go over them. You need to be sure that you don't pile more code onto these APIs or onto these mechanisms if you're using them. You should instead phase them out, reduce their usage, because they will go eventually. And eventually, not like in 10 years, but like security manager will take a while longer, but the other four, I don't think they'll be around for many more years. And if you're on 11, some things are already gone, like RMI activation and NASON, for example. Now, to ease migrations, I want to go over this list very quickly. Generally, I mean, like, you know, be a good and observant consumer of your dependencies and of your tools. Try to keep things up to date. Try to only use what is promised as behavior. Try not to use behavior that's like an implementation detail that might change. And if you do all of these things, then it will be much easier for you to update your new Java versions, which often requires you to update your dependencies as well. If you keep your dependencies and tools up to date, which is easily set, and I know it's not that easily done, but if you achieve that, which has good benefits on its own, right? You don't want to have something like, you know, Log4Shell or something happen and then be stuck on a Log4j version that you cannot update for whatever reason. Just as an example, you want to have your dependencies up to date anyway, and it gives you the added advantage of making it easier to update your new Java versions. And the last point specifically, build on each release. If you're running on, the current Java version you support, every LTS after that, the latest and the early access build. So if you're on Java 11 right now, I would ask you to build on 11, 17, 20 starting next week, and 21, for which the early access builds are already out. And if some of those failed, it doesn't matter. They don't have to fail your build pipeline. Just do it nightly. But be aware when things fail on your Java 21 EA build, because presumably you're going to be at that point eventually, and then you want to be able to use Java 21. Okay, let's talk about adoption a little bit. I'm going to make some guesses. Okay, so I want to ask you, the newest project that you run in production, for whom of you that is on Java version 8? So you're not using 11 or 17 production. Okay, that's very few people. Excellent, I'm not going to call you out. Who's on 11? That's great, that's the majority. So that's what I'm saying. Java 11 is slowly but resolutely overtaking Java 8. This is not representative, clearly, but 2 people versus, I want to say, a third or quarter of the group. Nice. Who is on Java 17 as the newest version running? Ha! As much as Java 11, second revision comes through, adoption of 17 from 11 looks really, really good as well. And now comes the part where I always struggle a bit. Who's on 19 or soon 20? Okay, good, good. One person, you're my lifesaver. It's uncommon, but it happens. And if you go from 11 to 17 and notice, you know what, actually it wasn't that much trouble. And if you go from 17 to 21 in fall and you realize, you know what, again, it wasn't that much trouble, maybe that gives you the self-esteem and the trust in your project and in this whole pipeline and in your dependencies to maybe then go from 21 to 22. Because that gives you performance improvements faster, that gives you more productivity features faster. It also gets you more developers faster, because imagine you can tell a developer that you're working on latest and not on Java 8. It's probably going to make a difference in hiring. Okay, I just have a couple minutes left. I want to speed through as much of Loom as I have available, but Loom has been covered extensively on the Java YouTube channel, for example. There's lots of talks about that, so I really think that you have a good chance to see this information elsewhere as well. But I still want to go over it quickly, and then at some point someone is going to drag me off stage and shut off my mic. I'll keep yelling, but then you can also meet me in the down there and talk to me. Okay, so Project Loom has the idea to develop JVM features and APIs for supporting easy-to-use, high-throughput, lightweight concurrency. That's one big thing. And new programming models. That's the other big thing. We're not going to get to new programming models, but the term here is structured concurrency. There's a JEP for that. That's a term that's being established right now in the Java ecosystem. Look out for structured concurrency. For the new programming models part, let's focus on the first three things. Let's go with the hypothetical HTTP request. You get the request, you pull out some JSON probably, you parse it a little bit, you create some Java objects to understand everything that's going on. Then you query the database and you wait. And then when the request comes back, you're processing the request, the SQL database request, and then stuff everything into the HTTP request and send it home. And you're using your JVM resources really well on step 1 and 3. And for step 2, you're just sitting there and waiting, and you're not using it that well. So how do you implement that request? You can do it synchronously. Your application clearly has a unit of concurrency, which is different requests that have to happen at the same time. And the JVM offers you a unit of concurrency, which is threads. They can do different things at the same time. So it would look like one request, one thread, simple to use, simple to write, blocks threads on certain calls. And this is where the problem comes in, because these threads, I'm going to call them platform threads from now on, wrap around an operating system thread. And that means you can have thousands. You can have tens and hundreds of thousands maybe, but you usually can't have millions. So at some point, this is going to drop off. And that could become the limiting factor. Not CPU utilization, not the memory need to your Java objects. It's the number of threads. So some people had a radical idea, which was, you know what, if threads are so expensive or like so rare, maybe we should only use them when we actually need them. So that created non-blocking APIs. You can do this with futures. You can use reactive streams. But it makes the code overall a bit harder to write, but specifically makes it harder to debug and profile. Makes it hard to track what operation is taking how long and where is it waiting right now. You often end up in stack traces that just end in a thread pool and you don't know what's happening, why you're here at this moment. And it's incompatible with synchronous code. Meaning, like, if you have a library that doesn't know that you're doing reactive, well, that sucks if it starts blocking somewhere. But it shares platform threads. It gives you great thread utilization. So again, we have a conflict here. Just like with Valhalla, where the conflict was design versus performance. Here, in Panama as well, by the way, where the conflict was safety versus the features you want to use. Here, the conflict is throughput versus simplicity. And this is where virtual threads come in. A virtual thread is a regular thread. It's an instance of the class thread. It has super low memory footprint, has very small switching costs because it's scheduled by the runtime, and it requires no operating system thread while waiting. So you can have, like this laptop can have easily millions of virtual threads waiting. We cannot have millions of threads working because I don't have a million core CPU in here, but waiting is super cheap. And that happens because the runtime has a carrier thread pool somewhere. And the idea is that when a virtual thread is doing something, it sits on the carrier thread, and the carrier thread is doing the actual work. And then when it starts to wait, the virtual thread says, oh, I'm waiting now. But the carrier thread goes away and does some work elsewhere. And so if you debug the virtual thread, it just sits in blocks. It's like great synchronous code. But the actually working resource is doing its job elsewhere. OK, and I think with that, I'm going to call it a day. Let me see. There you go. OK. So, as I said earlier, my name is Nicolai Parlog. I'm NipaFX on all the platforms, on Twitter, on Mastodon as well, on Twitch and on YouTube. But more importantly, maybe I work for the Java platform group at Oracle, and we also do a bunch of interesting stuff. If this interests you, if learning what's happening with Java interests you, go to insight.java. That's the best resource. It's basically a collection of links that points to the recent JEPs, that points to interesting mailing list discussions, points to good blog posts. Go there as a primary resource to basically, so next time you don't have to come to my talk. You're like, I know all that already, right? So you can enjoy your time elsewhere. Go to insight.java for that. Otherwise, go to the Java YouTube channel. There's lots of good stuff there. Finally, again, meet me at the conference if you have more questions. Thank you very much for your attention. I wish you a great Worksday Zurich.